Okay, in this section we're going to find the mass that's distributed over a plane. So let's consider that you have a flat plate like a disc of aluminum or a triangular sheet of steel or something like that. Okay, now in these cases we're going to assume that the distribution of the mass is continuous, and the formulas we use to calculate will contain integrals instead of finite sums. So take a look right here. So let's imagine a plate occupying a region in the XY plane, kind of like this circular region right here. And let's say we cut it into thin strips parallel to one of the axes. So I've given you one of the strips that's parallel to the y-axis. Okay, so we'll call the center of mass of a typical strip x tilde y tilde. So like for instance, the center of mass of this strip might be right here. And we'll actually identify the mass of each strip as delta m, or delta lowercase m, and that will actually represent the mass of the strip. Okay, then the moment of the strip about the y-axis would actually be x tilde times delta m, and the moment of strip about the x-axis would be y tilde times delta m. And so if we wanted to find the x value of the center of mass, we would actually calculate the moment about the y axis divided by the mass. So in that case we would sum all of the x tilde times the delta m's and then divide by the sum of the delta m's, and then the center of mass, the y value of the center of mass, would be the moment about the x-axis divided by the mass. So that would be the sum of all of the y tildes times delta m divided by the sum of delta m. But since we can't do a finite sum, we have to do an infinite sum, so that requires the integral. So we take this right here and then this right here, and we use integrals to define them. So therefore the moment about the x-axis would actually be the integral of y tilde times dm, and the moment about the y-axis would be x tilde dm, and then we would let the mass be just the integral of dm. Okay, so basically the dm is replacing the delta m in the sums. And then so your center of mass, to get your x bar, that would be my over m, and then to get your y bar, that would be mx over m. So you would take the moment about y divided by m, or the mass, and then you would take the moment about the x-axis and divide it by the mass, and that would give you the center of mass for a plane region. Okay, so let's take a look at an example. Okay, so in this example we're going to have a triangular plate that's shown down here, and it's created by the line y equal 2x, and then this vertical line here, x equal 1, and then bounded below by the x-axis. And it has a constant density function, so the density is 5 grams per square centimeters. And then it says find the plate's moment about the y-axis. Now you can do this with vertical strips or horizontal strips, so we can do it either way. So let's start with vertical strips. So I've drawn a typical vertical strip right here. This blue strip here is a vertical strip. The width of the strip is just dx, and notice that if I find the center of mass of this strip, since I have constant density, the center of mass would be, the point halfway between the strips. So right here, this distance from the y-axis, I'm going to call that x, and then what I have to do is find half the distance of the y value, and notice this point right here where it touches the line y equal 2x. That point is actually the point x for the x value, and then the y value would simply be 2x, so that point right there. So then the center of mass here would actually be, and I'm going to just kind of put it right there. So the center of mass right there would actually be the point XX, because it's x units from the y-axis, and then if you take half of 2x, you get x units from the x-axis here. So that's the center of mass. Okay, so that's that part of it. Now let me go ahead and take you down here where I put this information to work. So as I said, the center of mass is simply the point XX, and the length of our, in other words, the length is 2x. So that's the length of my strip, and the width of my strip is delta x. So if you multiply the length times the width, then the area of your strip would be 2x times delta x. And then the mass of the strip, from what we learned earlier, is just the density function times the area. So that would be the 5 for the density function, and then the 2x dx for the area. And then if you multiply that together, you get 10x dx. Okay, since the distance of center of mass from the, actually that should say y-axis. Since the distance of the center of mass from the y-axis is x, then the moment of the strip about the y-axis would be this x tilde dm, and we know that this x value of our center of mass tilde is x, and we know that dm is 10x dx. So if we multiply that together, we get 10x squared dx. Okay, so now to find the moment of the plate about the y-axis, we simply integrate what we got up here, which was the 10x squared dx. That's the moment about the y-axis. And so you know how to integrate that, so I won't waste time here, but you get 10x cubed over 3 and integrate it from 0 to 1. And the reason we integrate it from 0 to 1 is because if you go back up here and look at these strips would go all the way from here all the way over to here where x equals 1. So that's why we integrate from 0 to 1, because the strips would actually move left to right from 0 to 1. And so we get 3 1/3 there grams centimeters. And then to get the mass of the plate, I actually have to integrate the dm, which we determined up here was 10x dx, and if you integrate that, you get 5x squared, and then you integrate that from 0 to 1, you get 5 grams. And then putting it all together, remember that the x coordinate of the center of mass would actually be this value right here, 10/3, divided by this value, 5. And so when you take 10/3 and divide it by 5, you actually get 2/3. So the x value of the center mass would be 2/3 centimeters. And similarly, you would find the y-coordinate the same way using the similar calculation. Now, if you used horizontal strips, here, then actually, first of all, you would actually integrate from y equals 0 up to y equal 2 here, and then your strip here, the distance the strip would be from the x-axis would be y. So this point right in here that represents the center of mass, the y value would just be y, and the x value would actually be the sum of the corresponding y value over here, which is y over 2, plus the y value here, which is 1. So what you do is you take y over 2 plus 1, then divide it by 2, and if you simplify that, you'll actually get y plus 2 over 4 for the x value, and then of course y for the y value. Okay, so since the center of mass for the y value is simply y, and I told you the center mass for the x value is y plus 2 over 4. And now we actually know the length of our strip. So the length of our strip, if you start here, you have 1, and then if you subtract this small distance in between the y-axis and the where it hits the function, that distance, that x distance, is y over 2. So that would mean that the length of this strip is just 1 minus y over 2. Okay, and so another way to write that is 2 minus y over 2. So now the width is dy, so the area, if we multiply these together, 2 minus y over 2 times dy, we get 2 minus y dy over 2. And then also, if we do the dm, that's just the density function times the area, so that would be 5 times 2 minus y dy over 2. And also we know that the distance of the center, as I said, for the x was y plus 2 over 4. So the moment of the strip about the y-axis can be calculated by integrating this x tilde dm, which we determined to get x tilde dm. We just multiply y plus 2 over 4 times the dm. So we're taking the x tilde times the dm here, and we get 5/8 4 minus y squared dy. And then if we integrate that, so we integrate that, remember I said we're integrating from y equals 0 to 2. So if we integrate that, and I'll let you go through the math here of integrating, but if you integrate that and evaluate it from 0 to 2, you actually get 10/3 for the moment of the plate about the y-axis. And then if you integrate the dm to get the mass, you'll just integrate this function here from 0 to 2, and I'll leave you to do that, and you'll actually get 5 for that. And so the x coordinate of the plate center mass again is the same value as it was before. It should be the same in both cases. So it's 10/3 divided by 5, which is 2/3 centimeter. Now if the distribution of the mass in a thin flat plate has an axis of symmetry, then the center of mass will lie on that particular axis. If there are two axes of symmetry, the center of mass will lie at their intersections. And so these facts will often help us to simplify our work. Okay, so I'm going to finish this video. I've got some more examples I want to show you that won't fit on this video. So I'll put the remaining examples on one final video for this particular section.